Hi everyone! Do you have any idea about variance?
Excellent! It refers to a statistical measurement of the spread between numbers in a data set.
More specifically, variance measures how far each number in the set is from the mean, and therefore from every other number in the set.
And how about the importance of variance?
The variance is a numerical value used to indicate how widely individuals in a group vary.
If individual observations vary greatly from the group mean, the variance is big, and vice versa. In short, variance measures how far a data set is spread out.
Come on! Join us as we are going to discuss the analysis of variance.
Welcome
To H,
and Age,
the science enthusiast, statistics
lessons. For today's video, we are going to discuss the analysis of variance.
So what are you waiting for?
Let's get started! And here are the steps on how to calculate.
Variance. Step 1. Find the mean of the data set. Add all data values and divide by the sample size.
Step 2. Find the square difference from the mean for each data value. Subtract the mean from each data value and square the result.
Step 3. Find the sum of all the square differences.
And the last step is calculate the variance. ANOVA, which stands for Analysis of Variance.
It is a statistical test used to analyze the difference between the means of more than two groups.
And there are two types of ANOVA. First is the one-way ANOVA.
And the two-way ANOVA. One-way analysis of variance. In statistics, one-way analysis of variance is a technique that can be used to compare means of two or more samples. This technique can be used only for numerical response data. The Y usually one variable, and the numerical or categorical input data, the X always one variable, hence one way. How to perform one-way ANOVA by hand? A one-way ANOVA or analysis of variance compares the means of three or more independent groups to determine if there is a statistically significant difference between the corresponding population means. For example of one-way ANOVA by hand, suppose we want to know whether or not three different exam preparation programs led to different mean scores on a certain exam. To test this, we recruit 30 students to participate in a study and split them into three groups. The students in each group are randomly assigned to use one of the three exam prep programs for the next 3 weeks to prepare for an exam. At the end of the 3 weeks, all of the students take the same exam. The exam scores for each group are shown below. For Group 1, 85, 86, 88, 75, 78, 94, 98, 79, 71, and 80. For Group 2, 91, 92, 93, 85, 87, 84, 82, 88, 95, and 96. And for Group 3, 79, 78, 88, 94, 92, 85, 83, 85, 82, and 81. Use the following steps to perform a one-way ANOVA by hand to determine if the mean exam score is different between the three groups. Step 1. Calculate the group means and the overall mean. Step 2. Calculate the regression sum of squares SSR using the following formula, where n is equals to the sample size of group J, summation or the Greek symbol that means sum, xj the mean of group J, and x period the overall mean. In our example, SSR is equals to 192.2. Step 3. Calculate SSE. We will calculate the error sum of squares or SSE using the following formula, where summation, a Greek symbol that means sum, x sub ij, the I observation in group J, x sub j, the means of group J. In our example, we calculate SSE as follows. For group 1, we have 640.4. For group 2, we have 208.1. And for group 3, we have 252.1. And next, we will calculate the error sum of squares or SSE using the following formula. SSE is equals to 640.4 plus 208.1 plus 252.1 is equals to 1,100.6. For step 4, we are going to calculate the SST, the total sum of squares SST, by using the following formula. The SST is equals to SSR plus SSE. In our example, SST is equals to 192.2 plus 1,100.6. It is equals to 1,292.8. Step 5. Fill in the ANOVA table. Now that we have SSR, SSE, and SST, we can fill in the ANOVA table. The formula for DF treatment is K minus 1. In our solution, 3 minus 1 is equals to 2. The formula for finding DF error is N minus K. In our solution, 30 minus K is equals to 27. The formula for finding DF total is N minus 1. In our solution, 30 minus 1 is equals to 29. The formula for MS treatment is SST divided by DF treatment. In our solution, it is equals to 192.2 divided by 2 is equals to 96.1. The formula for finding MS error is SSE divided by DF error. It is equals to 1,100.6 divided by 27 is equals to 40.8. The formula for finding F is MS treatment divided by MS error. It is equals to 96.1 divided by 40.8. It is equals to 2.358. Note that N is equals to total observations and K is equals to total number of groups. Step 6. Interpret the results. The F-test statistic for this one-way ANOVA is 2.358. To determine if this is a statistically significant result, we must compare this to the F critical value found in the F distribution table with the following values. Alpha, significance level is equals to 0.05. DF1, the numerator degrees of freedom, is equals to the DF treatment and it is equals to 2. The DF2 is the denominator degrees of freedom equals to the DF error is equals to the 27. We find that the F critical value is 3.3541. Since the F-test statistic in the ANOVA table is less than the F critical value in the F distribution table, we fail to reject the null hypothesis. This means we don't have sufficient evidence to say that there is a statistically significant difference between the mean exam scores of the three groups.
And now, let us discuss the two-way analysis of variance. In statistics, the two-way analysis of variance is an extension of the one-way ANOVA that examines the influence of two different categorical independent variables on one continuous dependent variable. And this is how to perform a two-way ANOVA by hand. The two-way ANOVA compares the mean differences between groups that have been split on two independent variables called factors. The primary purpose of two-way ANOVA is to understand if there is an interaction between the two independent variables on the dependent variable. For example, you may want to determine whether there is an interaction between physical activity level and gender on blood cholesterol concentration in children. The interaction term in a two-way ANOVA informs you whether the effect of one of your independent variables on the dependent variables is the same for all values of your other independent variables, and vice versa. There are some assumptions to do two-way ANOVA, or we can say that these are the conditions for two-way ANOVA. The first assumption: your dependent variable should be measured at the same continuous level. For example, they are interval or ratio variables. Assumption number 2. Your two independent variables should be each consist of two or more categorical or independent groups. Assumption number 3. You should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. Assumption number 4. There should be no significant outliers. Outliers are data points within your data that do not follow the usual pattern. Assumption number 5. Your dependent variable should be approximately normally distributed for each combination of the groups of the two independent variables. And last, assumption number 6. There needs to be homogeneity of variances for each combination of the groups of the two independent variables. For example of two-way ANOVA calculation by hand. Suppose you want to determine whether the brand of laundry detergent used and the temperature affects the amount of dirt removed from your laundry. To do this end, you buy two detergents with different brands, the Super and the Best, and choose three different temperature levels, the cold, warm, and hot. Then, you divide your laundry randomly into 6 or pile of equal size and assign each or piles into the combination of Super and Best, and also the cold, warm, and hot. In this example, we are interested in testing null hypothesis. First is we have HOV, which means the amount of dirt removed does not depend on the type of detergent. The second null hypothesis is the HOT, which means the amount of dirt removed does not depend on the temperature. The example has two factors. First is the factor detergent and the factor temperature. At A equals 2, Super and Best, and B equals 3, in cold, warm, and hot levels. Thus, there are A times B equals 3 times 2 equals 6. Different combination of detergent and temperature with each combination. There are R equals 4 loads. R is equal to the number of replicates. This sums up to N equals A times B times 4 equals 24 equals 2 times 3 times 4 loads in total. The amounts of Y, which is IJK, of dirt removed when washing soap pile K, which is equal to 1, 2, 3, 4, with detergent, which is I, and I is equal to 1 and 2, at temperature, which is J, equals to 1, 2, 3, are recorded in the table. The table shown is the solution of our problem. It shows the group mean of the brand Super and Best, and also we have there the overall means of our solution. We have calculated all the means like detergent mean, temperature mean, and the mean of every group combination. Now, what we only have to do is to calculate the sum of squares and degree of freedom for temperature, detergent, and interaction between factor and levels. First, calculate the SS or within over the DF or within. We have already know how to calculate the SS or the DF in a one-way ANOVA. We calculated this, but in two-way ANOVA, the formula is different. For step 1, formula for calculation of SS is Y sub ijk are the elements in the group. Y, ij is mean of combinations. When we put the values and do calculations with this formula, we will get SS is and our answer in this calculation is equal to 38. Next is calculate the DF. DF is equal to R minus 1 times A times B, which is equal to 18. And calculate the MS, which is equals to SS over DF, which is 38 divided by 18, and the answer is 2.11. Step 2. Calculate SS detergent and DF detergent and MS detergent. Y sub I is the mean of detergent. Y is the total mean detergent and temperature. Here is the formula in finding the SS detergent. And the answer here is 24. Calculate the DF detergent. DF detergent is equal to A minus 1 equals 2 minus 1, and the answer is 1. Calculate the MS detergent. MS detergent is equal to SS detergent over DF detergent equals 24 divided by 1, and the answer is 24. Step number 3. Calculate the SSS temperature, DF temperature, and MS temperature. Y sub I is the mean of detergent. Y is the total mean detergent and temperature. Here's the formula in calculating the SS temperature. And our answer is 192. Calculate DF temperature is equal to B minus 1 equals 3 minus 1, and the answer is 2. Calculate MS temperature, and it is equal to SS temperature divided by DF temperature equals 192 divided by 2, and the answer is 81. Step number 4. Calculate SS interaction, DF interaction, and MS interaction. Y sub ij is the mean of combinations. Y sub I is the mean of detergent. Y sub j is the mean of temperature. Y is the total mean detergent and temperature. Calculate SSS interaction using this formula. And the answer is 12. Calculate DF interaction. DF interaction is equal to A minus 1 times B minus 1 equals 2 minus 1 times 3 minus 1, and the answer is 2. Calculate the MS interaction. MS interaction is equal to SS interaction divided by DF interaction equals 12 divided by 2, and the answer is 6. calculate the F-test or calculate the critical F value. If you found the F value less than the critical F value, then you will not be able to reject the null hypothesis.
And that's our lesson for today.
Please like and subscribe for more statistics lessons.